The first difference. What's the first difference in this table of values? So first difference means the difference between the y values. So from 33 to 25, if I subtract those, I see that it's going down by 8 units. 25 to 17, that's also a difference of 8. 17 to 9, a difference of 8. 9 minus 1, again a difference of 8. And another difference of 8. We have found the first difference in this graph. Now I'm also going to check the x value too, because if the x values are not also increasing or decreasing by a constant value, then the first differences of the y are not very meaningful. 5, 10, 15, 20, 25, 30. So this one is clearly increasing by 5 units. Now, the reason that it's significant for us to look at the first difference is because the first difference, if I have a constant value for the first difference, it will tell me that this table of values will graph something that is linear. So if the first difference is a constant value, then I know that the graph it creates will be a linear relation. So once again, a linear relation, it means that we are going to have a straight line. Okay, so are these linear relations? Yes, no, or not possible to know. Let's look at the values here. The y, negative 40 to negative 32, I know that this is increasing by 8. Negative 32 to negative 24, that's increasing by 8. And the last one, negative 24 to negative 16, increasing by 8. Now, I have 87, 85, 83, and 81. This is all going down by negative 2. So we've got a consistent first difference in the x and the y. What I know about this is that this is linear. Okay, our second one, 73 to 66. That is going down by a value of 7. 66 to 58, that is decreasing by 8. And 58 to 51, that's decreasing by 7. Now, we already know that this is not a linear relation because the y values are not increasing or decreasing at a constant. So no, it's not linear. Last one here, 6, 8, 10, and 12. Well, this is very obvious that for all the values here, we're increasing by 2. Let's just check to see that the x value is also increasing at a constant rate so that we could say it's linear. So we have increasing by 4, increasing by 3, and increasing by 4. Well, that's a bit of a problem because we're going up by 4, going up by 3, going up by 4. Now, even though my first difference for the y is the same, the difference in the x is not the same. So I have to conclude that this isn't linear. Let's create a table of values to graph the relation y is equal to negative 2x plus 1. So when we're creating a table, we're going to put x on the left side, and then we have the y on the right side. And the y, we're going to make this equal to the equation. So y is equal to negative 2x plus 1. So what we're going to do, let's pick a bunch of numbers and we're going to substitute it in. You could pick any numbers you want, but you need to have a minimum of 3 so that it is obvious whether this is going to create a line or not. I'm going to pick maybe 6, 4, 2, 0, and negative 2. So let's substitute it into the y. When I substitute it, I'm going to have negative 2, and we're multiplying positive 6 plus 1. So this is negative 12 plus 1, negative 11. Our second value, x is 4. Let's substitute it in. 2 times 4 plus 1. Negative 8 plus 1, that gives us negative 7. Right? Our third one, negative 2 times 2 plus 1. Negative 4 plus 1, that's negative 3. Negative 2 times 0 plus 1, and we have 1. Because the first part gives us a 0, but we're adding a 1, so we still have a 1. Finally, we have negative 2 times negative 2, and we're going to add 1. This is 4 plus 1, that gives us 5. All right, now let's create a plane, Cartesian plane, so that I can plot these points. 6 and 11, this is off of our graph, but that's okay that it's off our graph because eventually we're going to put arrows at the end to show that our line continues. So we have 4 and negative 7. 4, negative 7 is here. 2 and negative 3. 0, positive 1. Negative 2 and positive 5. Draw a line. So even though these are the only points that are within the field of view for this graph, I'm going to put an arrow at the end to show that this line continues. So this implies that 6 and negative 11 is also a part of this graph because that would be somewhere down here. And if I extended the line, it would pass through this point. Now we have drawn the graph, but we also have to make sure we include the equation. So it's important for us to include the equation because this is like the title of my graph. Y is equal to negative 2x plus 1. This is the name of the line, and so I needed to label it. Okay, so quick hint here. When you are graphing, you need to include two things. One, arrows at the end of your graph. Secondly, you need to include the equation of the line. Let's do another example here. Create a table of values to graph the linear relation of y is equal to x plus 5. We have x and y is equal to x plus 5. I'm going to pick a couple of values. I will say -3, -1, +1, +3, and +5. Now, really, it doesn't matter what numbers I pick because a line is just comprised of many numbers. So we have -3 plus 5. This is equal to +2. -1 plus 5. This is equal to 4. +1 plus 5. That's 6. 3 plus 5 is 8. And 5 plus 5 is 10. So we're going to use our table. This is our x coordinate, this is our y coordinate, and we're going to put it on the Cartesian plane. So first we have -3 and 2. So here's -3 down to 2. -1 and +4. Oops, I made a mistake here. -3 and +2. I made it -2 instead. -1, +4. 1 and 6. Oops. 1 and 6 is up here. 3 and 8. And finally, 5 and 10. Okay, our line will be here. And once again, don't forget to put arrows to show that it continues. And we need to label it with the equation. Y is equal to x plus 5. Right, pause the video, try these questions on your own. Graph these two equations onto the Cartesian plane and determine whether these are linear relations. Right, on to the next part. Now remember we talked about the partial variation. Partial variation is represented by the equation y is equal to mx plus b. You'll notice that when we graphed things, this was in the form of y is equal to mx plus b. Now the reason that it is because we only want to find the y value, and it already says y is equal to this. But sometimes we have an equation that's represented in the standard form, where I have ax plus by plus c or minus c, and it's equal to 0. And a, b, and c are numbers. They're coefficients in the case of a and b. This is called standard form because it looks very standard. It looks more organized than this form. We know that this is going to be a line because we said that if I have the value of x, it's part of my equation, and the x has no exponent or the exponent of 1, which is invisible, we know that this is going to be a linear relation. Now we know that it's a linear relation because the x has no exponent other than the invisible one. Now, if we have an equation that's in standard form, we can still use a table of values to graph it, but we need to rearrange it in the form of y is equal to mx plus b so that it's easy for us to put it into the table of values. So let's start here. We have 3x minus y plus 2 is equal to 0. Now, I need to rearrange this equation so that I've got y on this side, and on the other side, my values are mx plus b. We're going to move everything the way that we moved things in algebra. So I'm first going to move my 3x and my positive 2. So we have negative y is equal to negative 3x minus 2. I'm not finished yet because remember, y is equal to mx plus b. The coefficient of y is a 1. It's a positive 1. We've got a coefficient of negative 1, which means that this is not completely simplified yet. I need to divide both sides by negative 1 so that I have a positive y. All right, I'm going to take this and I'll divide by 1, negative 1. Now that gives us positive y on the left side, and on the right side we have positive 3x and positive 2. So the equation in y is equal to mx plus b form would be y is equal to 3x plus 2. Just a quick side note here, in case you were wondering, another way to rearrange it is I could just simply move the y to the other side. We know that this is subtracting y. So if I made it on this side, I could have a positive y, and we didn't have to do these two steps in the middle. Anyway, if this works out for you, great. If it doesn't make sense, follow the ways that we did it before. So more examples to rearrange to rearrange the equations from standard form to y is equal to mx plus b form. Okay, let's start moving things one at a time. I'm going to move the x and the constant. So we have 2y is equal to negative x plus 10. Now, this is not finished yet because we have a coefficient of 2. So we need to divide everything by 2. 2y divided by 2 is equal to negative x divided by 2 plus 10 divided by 2. Let's simplify this again. Y is equal to negative x over 2, or you could say negative 1 over 2x plus 5. So just a side note, if I wrote negative x over 2, this is the same as saying negative half times x. This is also the same thing as saying negative 1x over 2, or I could still say positive x over negative 2. As long as my x is still associated with the numerator, this would work. And our negative sign, it could go with either the numerator or the denominator, just can't be part of both. Let's do this example. Negative 2x plus 3y plus 6 is equal to 0. Let's rearrange this. 3y is equal to 2x minus 6. Now we're going to divide each term by 3. So 3y divided by 3 is equal to 2x divided by 3 minus 6 divided by 3. Next row, y is equal to 2 over 3x minus 2. And it's okay if you have a fraction. Leave it as a fraction. It's easier to deal with than converting it into a decimal. Last example here, 3x minus y plus 8 is equal to 0. Now, just as a strategy, because this is a subtract y, I want to move the y to the other side first because it would reduce all of my work to just one step. So I have 3x plus 3x plus 8 is equal to y. That's the same as saying y is equal to 3x plus 8. Try this question on your own. Now, one more example here. Let's use a table of values to graph this linear relation. We are given a linear relation in the standard form, so before I can make a table of values, I need to convert this into y is equal to mx plus b form. X minus y minus 4 is equal to 0. I could have negative y is equal to negative x plus 4. I'm going to divide each term now by negative 1. So negative y divided by negative 1 is equal to negative x divided by negative 1 plus 4 divided by negative 1. And our equation becomes y is equal to positive 1x minus 4. Let's create our table of values. We have our x and y is equal to x minus 4. Different values that we'll put in, I will say 3, 0, and negative 3. 3 minus 4 is negative 1. 0 minus 4 is negative 4. And negative 3 minus 4 is negative 7. Let's plot this on our graph. First, we have 3, negative 1. Next, I have 0 and negative 4. And finally, negative 3, negative 7. I'm going to combine all of these lines together, all of these dots together. And we have this line. Let's label it y is equal to x minus 4. Right, so that is the lesson for